Hello guys, welcome to my channel Analytics with Ashish. So in today's video, I'm going to talk about how do we do labeling and what is the importance of labeling in machine learning classification problem. So for this particular project, I have taken the data from here, this location. You can get this location in dataworld.com. So I have basically this YouTube data from these 5 different channels. That data I have downloaded here. So I have these 5 different files and which has YouTube data collections. So let me import the libraries, loading the data. So I just located it into my data folder and looked into this particular files. Okay, and then I see that okay, I have comment ID, author, date, content, class, these different information. So I'm just trying to make it a little bit better. So like I decided my base path for the data is dot data, and then from here like list all the files to the directory. So I'm os dot list directory and then giving the base path. So that will basically gives me all the files which are saved into this location. So that's how I see my 5 different files. Now, because I want to access these files, so what I'm going to do actually, this is not in my current directory, it is in my working directory data. So, oh, sorry, it is not in my working directory, it is inside the folder data. So that's what I'm going here. I'm joining this base path with the CSV. CSV is just, it is reading, like each file in this particular. So like if you want to see that, it's simply doing this. So it is basically reading all the CSV file, but here it is joining this with the base path. So that base path is this one. Okay, and that's how it is reading my data frame. So the data frame is basically here. It is a list of data frame. It's not a data frame. So you can see here this. And if you want to see DFS, so it's just a list of data frames. Okay. Now, if you want to put that all the data frame into single one, so for that we have pd.concatenate, and when we do that, so now we have one single data frame, which is the combination of all the data frames. Now, if you see the shape that has increased, so now we have 19,956 rows, which for earlier it was less, I guess. Earlier it was only 369 rows. Okay. Yeah, so the next thing which we are going to do here is like sometimes we don't have the proper naming convention or proper name. So what we are going to do here is like we are trying to rename the name. So we are renaming content with text and class with label. So now we can see that we have text and label. So these are the 2 columns which we have renamed. And now this is just a seed for the order of the rows. So like, yeah, so we will, every time whenever we run, we will get the same order. So that's why we have this one. Now, now we have this function. Like what I want to do here is all the things which I did here, that basically I put this inside one function. So that I just like explain to, that is just for explanation purpose, but like I just created this everything into this folder, this function. So once we load the label data spam data set, the base path, and then we are giving the CSV files. From that CSV files, we are reading the DFS. We are concatenating all the list of the data frames, and then we are renaming those columns from the data frames, and then we are generating this, and then we are also resetting the index. So now this is the function which we have created, and now let's just load the data set. So I just call this function, and now I have this data set here. Okay, so now it has like, okay, all the nice things. So let me delete these things. This is not needed. This is not needed. This is not needed. Not needed. Not needed. Okay. So let me do this from the beginning. And this is our data set. So here, if you see out of how many labeled as 1 and how many labeled as 0, this is important to see if we have any unbalancing in our target data set. So that's why we are checking it here. We can do the same thing in the same thing which I did here. I'm just printing this into this value counts for each class is this, basically the same thing. And I'm just using the plot dot py, where I'm interested to see the pie chart for the y for the label column, and then that's the title. Okay. Now in this case, what I'm doing actually, like because I don't need all the columns here, because I'm mostly interested into text column and the label column. That's why I'm going to drop those columns which I don't need, and that's what I did. So right now in our df underscore labeled data frame, we have only these two columns, text and label. Okay, now let's split the data set into training and testing. And whenever we do split in training and testing, sometimes what happens if we have 80% training and 20% in testing, the target level, because it just randomly choose that, right? So sometimes like the target count can be different in train and testing. So like maybe if you look into the only training data set, the target this target balance, the targets count can be like 90% or 95% and only 5% in the testing, and we don't want that. We want that the ratio should be nearly same, and that's why we have something called here, which is stratification. So that's take care of that the target count also should be same in each split. So here nothing much, all it is doing actually is that we just decided our x variable, which is our predictor variable. So we just drop the label column or target label column. Why? We are only taking the target one, and then we are using the train test split from the sklearn. Here we are using this particular argument as positive. You can even see from here. So stratify is generally set to none, but by default it is none. But if you want, then we can use the class label. Okay, so that's what basically it does. You can read about it. So let's run this one, and then we can see there are 1564 comments for training and 392 for testing. Okay, this is just to create subplots. Now let's see what is the ratio, and we can see the ratio is nearly not bad. As you can see, this is 1, this is 0, this is 1, this is 0, so it is nearly same. So that's good. So yeah, out of 1564 and 392, though we have different counts, but the target count ratio is same, so that's good. Now here we are doing this vectorization. So okay, because now we have the training data set here. So this is a text processing, right? So we have this. Let's see the text one. So that's why we need to process this text, and that for that purpose we are using this count vectorizer. So I'm using this count vectorizer here. Just we created that object count vectorization n-gram n range is 1 5. Let's do this, and now we are using this function calculate accuracy. So it has everything. So it is taking training, x training, y training, x test, y test. Okay, and then as a model we are using multinomial naive Bayes because that is good for the text data. And for vectorizer, we are using this vectorize to process the text data. So first thing we do is vectorize the text training data, the text column, okay, into the list, and then we process it, and then we are passing that process data xtrain vectorization into this model crep.fit, which is basically my base model, and then we are passing our training and training y, training x, and training y. And the same thing we will be doing in our, like once our model is fit into this training data set, then we are using the same model to predict the X text vector. So we just pre-process our test data also in the same way, like we have the training one, and then we have just used the model to predict the test data, and now we are measuring the accuracy. So that's what the function is doing. Now let's call the function. Now before calling the function, we want to store our data or result somewhere. That's why we are initializing this dictionary here. So now in that dictionary, because in dictionary we have key and value pair. So in key, we can have the model name, and the value we can have the score. Okay, so that's the model, and that's what we have created. So now we generate three different cases. The first case is random labeling. So though we have the label here, but we just want to like make importance of like calculate or understand the importance of right labeling. So in the first thing, what we are going to do is like we are just generating the random labels, and then we just assign that random labels to any other text, you know. So let's do that here. That's what it is doing. So the random function is like, I'm just showing the how this random function works here. So I'm saying that okay, you have two values, 0 or 1, and then we need like 10 different values, you know, like so like for 10 you can create 0 1 randomly. And because in our training data set the shape is I don't know, I think it's 1400 something, so that's why we are giving this extend shape here. Let's see if you want to see that. So 1564, so it will generate those 1564 randomly 0 and 1, and then it will assign that into random labels. That's the new column which we are creating. So right now this is an NP array, and now what we are doing actually is like, as you can see, calculate accuracy, that is this function here, calculate accuracy. And in this function, rather than xtrain ytrain, we are passing this random labels. So here this is going as our random labels. Okay, so now when it will go, so as we can see here, the test x and test y, they remain same. So like for that we are using all the default, the correct one, but for this one we are just changing it. Okay, so now we change the random labels, and the accuracy which we are getting here is 53%. So the randomly we are getting 53%, but the idea is if you try to run this again, it will change, because every time we are assigning random 0 and 1, right? So let's just run this one more time. Now we are getting 49. Let's run this one more time, and then we are getting 44. So it is randomly changing every time. So for that purpose, what we have decided to do here, actually let's run this 10 times. So we are going to run this for 10 times whenever we are using this thing. So that means like we don't care about this value, we only care about the number of iterations. So number of iterations is 10. So that's why every time we are assigning this random labels, and then we are taking the average. I think I just run this one, so let's just see the random access. So in this like this is the list which I created. In this list, empty list, every time I append the score. So this function is basically giving us the score, and then we just append it as a score. So these are the different, if you want to run this again, then you can see every time it will change this. So these are, oh, okay, sometimes we even got to 62% of accuracy, that's not bad. so now if you, so that's our 10 different okay labels. And ACCS actually is the accuracy score, so that's another dictionary, and that dictionary is empty dictionary, and this is where we will be loading our results. So here I just created this average of all the random, so you see, like divided by the length of them, and then the random labelings right now we get is 52%. So with random label, where the label is not important at all, we just assign random labeling, and then with that we were able to get 52% of accuracy. Now case 2, where we are going to train our model with the true values, you know. So for the true value, again we are passing the same function, we are calling the same function. This time we are passing xtrain and ytrain. Ytrain is the actual ytrain which we have given by the data set, and this time we are putting that result into our dictionary, where right now we have only one key and value. Now we are adding another key which is called true labels, and then with that we are assigning this true accuracy in that one. So let's see that. With this we are able to get 92% of accuracy. Now let's see our dictionary, and then we can see that with the random it was 52%, and with true label it was 92%. So this is kind of very good, because now you have kind of decided the two the lowest and the highest point, you know, and now you can you can do multiple things. You can create rules for your own data set. So for that purpose, what we are going to do, third thing we are taking, like where we are assigning our own label. So in rule-based labeling, we can decide multiple things, like we can come up with our own rules that if this is the case, then we say that, okay, it is a spam. If this is the case, then it is not a spam. Basically, yeah, that's what our target variable is about, whether it is a spam or not a spam. So in this case, right now, we can see our pandas is, this is a, okay. So this is basically like you try to look for example, like if there is any word in the comment section, if there is a word like free or subs or HTTP, that means those comments are most likely go for spam, and that's why whenever we see these kind of things, then we mark them or label them as spam. So that's what we are trying to do here. This is just to showcase that how this works. So for label in xtrain.txt, so it is going into and then putting all the comments of the advanced series, and then first it is converting them into lower, and then it is finding if free in the label. If free word is in any of the comments, then print 1, or if it is not, then print 0. So that's something like this. How this is how we can label the things. Okay, right now I see all the zeros. There should be at least one. Okay, yeah, we see someone here. Okay, so this is just for the display purpose. The function is here. So we have created this function labeling rules, and then here we will be passing those labels. So that label will get converted into lower first. Then we can define our rules. So if free, like I have used only free here, but this is the better way to apply multiple rules. So we just created one list. And here we are saying that free in X, subs in X, and HTTP is in X. If any rules, return 1. If any of the rules fulfill any of them, then this is like a or. If any of them fulfill, then you put 1, otherwise you put -1 as no label. So let's run this function, and now let's label it. So now we have all the label as -1 and 1. Okay, now let's put those labels into an array, and now once it is an array, right, create the automatic label version of xtrain by removing the points with no label. So here what we are trying to do actually is we are only using those one where they are 1. So let's just see this one, xtrain and so on. So now we have only out of from 1500, now we have only 389 records. Okay, so now if you want to see this one, right now if you see this one, and you can see it has all the ones. So now we are only looking into those one where we have only ones, not -1s. Okay, and now here we again check the calculate accuracy, and then we are only taking that one where they are not spam, where they are spam, sorry, yeah, where they are spam. So let's just do the first iteration, and then we can see the first iteration. With that we are able to identify a 51% of accuracy. That is not good at all. Now we are going to draw the this graph, where this yellow line is basically the random labels, which was around 52%, and the true labels is this one. And now the first iteration is somewhere here, which is even lower than random labels. That's so bad. So now apply the rules to the data frame of the comments, cast the resulting labels to numpy array, delete all the points with no labels. Calculate the accuracy of the model using the automatic labels which we have created by creating the rules, and save the accuracy of the plotting. So that's what we are basically doing here. The same steps here, the every steps is the same steps here. And now let's do the second iteration. In second iteration we have added some more rules. Here in this case we are saying the spam rules is like if there is free, subs, gift, follow, HTTP, then it is spam, and if it is having this one, then it is not a spam. So this time we are having 0, 1 and -1. So 0 when it is not a spam, 1 when it is a spam, and -1 when we are not sure, and those are the one which we will take them out, because we are only interested in 1 and 0. And this time when we run, then we are getting the accuracy somewhere here, which is good, which is we are getting around 65 to between 65 and 70. Now let's do the third iteration. This time what we are trying to do here, we are saying that okay, number of characters is also important, because it is identified when we are doing some ETA, then we get to know that in spam comments there is the number of characters are more as compared to not spam. Oh, not spam, yes. So and that we have seen from here as well. So in this case, we are only taking the not spam one, and then we can see the number of comments are like this is how they are distributed. So we can say the majority of not spam comments have the word count somewhere around 30. That's the frequency here, and that's the number of counts. So that's how we have created this length. So in not spam, we have added one more rule. The length should be less than 30, and the spam rule is the same one. If there is checkout, then we will take that out as well. So now we have three labels, 0, 1, and -1. We will take that -1 out every time. So we are calling this one label given rules, and that label given rules is basically this one, and we'll take those -1 out. Okay, so let's run this one, and this time our accuracy is getting somewhere around 78.01%, which is good. So every time we can see that we are increasing, we are reaching towards our the highest point. So that's good. So now we can keep on doing these things and then come up with our own rules. So we can check, we can verify that the no spam comments. Or if you can find something here, then you can you can see that. To me, it looks like everything looks good. There is no spam comment. This okay, and then we have some check spam comments. So these all are like spam comments. We can see that okay, guys, you should check out this extraordinary. Please subscribe to my channel. So someone is promoting their own video or their own channel into this video. So they are basically spam. So that's what it is. And now we have this one. This is basically a prototype of calling all the functions. So here you can create your own rules. Here you can create your own rules for not spam, create rules for spam rules, and then if it is 0, it's good. If it is 1, it is good. If it is -1, when we are not fitting in any of these rules, so that means you need to take those out. And so this is basically to create your baseline. So we have two different endpoints, and then we are running our experiment multiple times, every time adding new rules to achieve the high accuracy. So that's it from my side. Hope this helps. Thank you. If it helps, please like, subscribe, and comments. Thank you.